Welcome students. We were already doing chapter number 3, that is gravitation. So let us start. First of all, I gave you the assignment. Amit buys few grams of gold at the poles as per the instruction of one of his friends. He hands over the same when he meets him at the equator. Will the friend agree with the weight of the gold bought? If not, why? Now first of all, let us see what the question is saying. We know that this is the shape of the earth, where let this be the center. Now RP is the polar radius and RE is the equatorial radius. Now what friend has asked Amit to buy gold at this point, that is at the poles, and then he must give him this gold at this point, that is equator, on the equator, near the equator. Now we will try to solve. Now the question is asking, will the friend agree with the weight of the gold? The answer is no. I am telling you that gravitational acceleration is equal to G is equal to Gm upon R square. We know, we have already done. Now gravitational acceleration is Gm upon R square. This is constant, but we know universal gravitation constant, the value is constant. Mass of earth is constant, but radius of earth is not always constant, because we have seen Rp is less than that of Re, that is the radius at the poles, because earth is flattened at the poles and bulging at the equator, so Rp is less than that of Re. So gravitational acceleration is inversely proportional to R square, we know. So that means that at Rp, because the value of Rp is less, so gravitational acceleration at poles will be more than that of at the equator. Gravitational acceleration at the poles will be greater than that at the equator. So I have to tell you that weight is equal to mass into gravitational acceleration, that is W is equal to mg. Now weight, whatever weight he is taking, few grams of gold he is taking at this point, it will be heavier, and when he reaches this point, due to less gravitational acceleration, this quantity of gold will become less quantity, that is it will become, the weight of this quantity will become slightly lesser than that the quantity which Amit got here, weighed at this point, that is at the poles. So the friend will not agree with him, because he has asked me that quantity, but here at equator or near the equator, the weight of the gold will become less. Now we will start our chapter, and today we are going to do numericals based on free fall. We have already studied the 3 equations of free fall, that is V is equal to U plus, let me write down again, V is equal to U plus GT, H is equal to UT plus half GT square, V square is equal to U square plus 2GH. Now these are the 3 equations. Now first of all, we must see what are the common factors here. See, U is common in all the 3 equations, and G is also common, that is acceleration is also common. But in this case of free fall, G is always constant, and we take it as a constant, and the value we take is 9.8. And if it is given 10, then we take 10, unless if it is not given in the question, we must take G is equal to 9.8 meter per second square. So first of all, if we have to solve any question, we have to find out the value of u if it is not given. So this we must understand. And now let us start doing our question number 1. Before I can't write down the question here. I have given in the notes, so you can see there. To estimate the height of a bridge over a river, suppose there is a river and there is a bridge here. A stone is dropped freely in the river from the bridge. A stone is dropped freely. Freely, that means it is dropped from here, it went till here. So this is the water surface. To the stone takes 2 seconds, and the stone takes 2 seconds to touch the water surface in the river. Calculate the height of the bridge from the water level. Here g is equal to 9.8 meter per second square. So he has given. If it is not given, even then we have to take the value of g, that is 9.8 meter per second square. Now see, we have to calculate the height of the bridge. Now we will see that here u is given because u is 0. So we know the value of g, we know the value of u, that is 0. Now we don't have to find out. In this question we are not required to find final velocity. So we will not use this formula. We will also not use this formula because it contains v. Here it also contains v. So we will see, we have to find out h. So we have to see only those formula which contain h. Now these are the two formulae which contain h. Now first, second, let us see second first. Third equation. Here it is gh, but we are also not knowing the value of final velocity v. So we will discard this equation. So we will solve by this equation, that is second equation, h is equal to ut plus half gt square. Now we will write down h is equal to ut plus half gt square, and we will put the values. H is equal to u is 0, time taken is 2 seconds, plus half, g is 9.8 into time is 2 seconds, 2 square. So it will come out to be, this will become 0, half into 9.8 into 2 into 2. So this 2 cancels with this 2, and h is equal to 9.8 into 2. H is equal to 19.6, and since height must be in meter, so the answer comes out to be h is equal to 19.6 meter. Now see, what is 19.6 meter? It is the height of the bridge above the surface